first thing I want to do is just look at this little differentiation. I've got y equals cos of x squared. Now how we do that is we'd use the chain rule. What we would do is we'd let u, so that's supposed to be u, equal to x squared, and we'd let, therefore, y would equal cos of u. Differentiate that, and we've got du by dx equals 2x, and we got dy by du equal to minus sine u. So therefore, dy by dx equals dy by du times by du by dx. It's the chain rule. And what we get is we get 2x times minus sine u, so minus 2x sine u, and we know that u was x squared. So we get equals to minus 2x sine x squared. Well, the next thing we're going to do is we're now going to look at this integration here. We're going to look at the integral of, let's have a go at, say, x sine squared x, something very similar to this, dx. And what we're going to do is, again, we're going to look at this as a composite function. We're going to imagine what would happen if we make the substitution that u equals x squared. So let's put that in. And this is a much simpler thing to do, but the only problem is we've now got two variables, x, u, and dx. So let's see if we can find a way of putting this in so that we get it all in terms of u. So let's differentiate this, because we need to do something about this dx. So we've got du by dx will equal 2x. So effectively, if we divide both sides by 2, we've got a half du by dx equals x. So we can replace that x with a half du by dx. So let's replace that x. I'm just going to change the order. Imagine the x is here. And what I'm going to do is replace it with a half du by dx. So we times that by a half du by dx. And we've got dx of that. So this will just leave us with the integral of a half sine u du. Now, strictly speaking, what you can do is you can make this a little bit simpler, is you could possibly, some students quite like splitting up the du by dx in here. It's not strictly something you can split up, it's not really a fraction, but it actually works in the same way. So what we could do here is realise actually we've got a half du is equal to the x dx. So replace the x dx here in here. Okay, so effectively this here will equal the same as all of that there, and so it gets replaced by this in our expression. And then we just get something that's much easier to integrate. Half sine u du is quite straightforward. Let's integrate that, so that will equal, sine u comes from minus cos, so we've got minus a half cos u plus some constant. We know that u is equal to, go back here, x squared. So therefore, our integral is, if we put the x back in for u, it's equal to minus a half cos x squared plus c. And that's how you do integration by substitution. What we've done, let's just recap. What we did was we didn't really like this x squared bit. We realised actually we've got a bit of a composite function going on here, so let's do a substitution in the composite function. And what happens in these types of questions is actually when you do the differential, you'll find that actually this is effectively a reverse chain rule. This has come from very similar to this chain rule problem here, apart from the fact we didn't have the minus 2. So actually, if you just done this, you wouldn't really go through all this rigmarole. You'd realise because we don't have the minus 2, then we times by minus a half to get the same expression. Okay. So quite often reverse chain rules can be done by substitution. There are also some questions which aren't reverse chain rule that are made easier by integrating by substitution. And one we're going to look at now is the integral of x times by the square root of x plus 1. Now, the fact we've got square root of x plus 1 would be much nicer if we actually could have the square root of x to times by x plus 1. That would be much easier. So let's see what we can do about this, or something similar. So this is the complicated bit. So let's let u equal that, x plus 1, and see what happens. Differentiate like we did last time, du by dx, and you see that du by dx, x differentiates just gives 1, the 1 disappears. So let's substitute in. We can replace x plus 1 with u, so we've got the square root of u. We can replace the dx, well if you bring this up, you just get du equals to dx with du. Or we can just realise du by dx is just equal to 1, so put du by dx in there and cancel out the dx's. We've got this x here though we need to deal with. So what does x equal? Well, we know that u minus 1 will equal x if you rearrange this equation. So let's put u minus 1 into here. And this therefore gives us a simpler expression that we can multiply out. We can do root u times u, that's just u to the half times u to the 1 is u to the 3 over 2. U times minus 1 gives you minus u to the half, sorry, root u times that. And we got that, and this is much easier to integrate. So we can now integrate this, add 1 to the power, divide by the power, so we get u to the 5 over 2, and we divide by that is the same as times in by 2/5, minus, add 1 to the power of that, so you get 3 over 2, so we times that by 2/3, and you get a plus c. Remember, we want to put the x's back in, so therefore we get 2/5 x plus 1 to the 5 over 2 minus 2/3 x plus 1 to the 3 over 2 plus c.